All right, let's dive into a really wild idea. We're going to talk about the Big Bang, but not as an explosion. We're going to look at it as a geometric failure, a global fracture in the very fabric of reality itself.
You know, we all have that mental image of the Big Bang, right? A single point that just explodes into space. But what if that's completely backwards? What if the Big Bang wasn't something that happened in space, but was the moment space itself cracked?
So to really get this, we have to ask, what was there before the crack? And the answer, in this framework, isn't, just nothing. It was something else entirely. It was a state of absolute, almost unimaginable perfection.
I want you to picture this, a single, unified field of space-time, and it's oscillating, just humming, perfectly in sync, everywhere all at once. It's kind of like a perfectly still infinite ocean. There are no things in it. There's no before, there's no after. This perfect rhythm is what physicists call global phase coherence. It's the ultimate state of order.
But here's the catch with perfection. It's fragile. A state of absolute balance like that is actually incredibly unstable. Think about trying to balance a pencil on its very tip. Yeah, it's perfectly balanced for a split second, but it's also in a state of maximum tension, just waiting for the tiniest disturbance to come crashing down.
And that's the whole point. That perfect, infinitely synchronized state, well, it just couldn't last. It was basically destined to fail. The fact that you and I are here, that reality exists at all, is the ultimate proof that perfect order had to break.
So you see, the story of our universe isn't really a story of creation from nothing. It's actually a story about a failure. It's the story of space-time failing to stay perfectly in sync with itself.
Okay, so how did this failure play out? Well, it seems to have happened in a sequence. First, that perfect synchrony, that perfect phase coherence, it became unstable. Then, boom, a spontaneous fracture. Space-time loses its global rhythm. This creates what are called phase gradients. Just think of our cosmic ocean again, but now different parts of it are oscillating at slightly different rates. And it's from these differences, these new gradients, that our familiar concepts of time and space literally crystallized into being.
So there you have it. The Big Bang, in this picture, was just a spontaneous loss of that perfect synchrony. It was the exact moment space-time fractured, and the universe as we know it is just the after effect.
And this distinction is absolutely critical. We're not just playing with words here. We have to shift our thinking away from an explosion in space to a fracture of space. It wasn't an event happening on some pre-existing stage, it was the stage itself shattering into existence.
And everything we see, literally everything, every star, every galaxy, you, me, every particle, it's all just the lasting consequence of that one original fracture. We're all basically just scars left behind on the fabric of space-time.
And this just completely changes what matter is. In this model, matter isn't some separate thing that you place inside of space. Matter is space. It's what space is doing in certain locations. It's a region where that space-time oscillation has gotten tangled up, twisted into a stable, self-locked knot. So particles aren't things at all, they're just trapped geometry.
I mean, think about it. This one single idea reframes everything. Matter? Just a knot of space-time. Gravity? Well, that's not some mysterious force, it's just the pressure of space-time trying to relax and smooth itself out again. And dark energy? That's just the leftover tension from that original fracture. Even time itself becomes simpler. It's just the beat, the rate at which space-time oscillates.
So, why are we so excited about this perspective? What makes it so powerful? Well, it's because it doesn't just describe our universe. It actually seems to offer a reason for why it is the way it is. And by doing that, it starts to just dissolve some of the biggest, most stubborn paradoxes in all of physics.
And all of a sudden, these huge problems start to make sense. The singularity at the beginning of the Big Bang? It just disappears. It wasn't an infinitely dense point. It was just a state where space-time was perfectly locked. The arrow of time? Well, that's just the fact that you can't unbreak a fracture. And the universe's incredible uniformity? That's just a faint echo, a lingering memory of that perfect synchrony that existed before the whole thing broke.
What this all means is that we start moving away from a picture of the universe that needs a bunch of mysterious forces and finally two numbers that we can't explain. Instead, the biggest cosmic mysteries we have just become logical. They become necessary consequences of a single geometric event.
And this leaves us with one last, truly profound thought to chew on. If matter is a scar, a knot on space-time, then what are black holes?
Maybe they aren't the cosmic destroyers we always imagine them to be. What if they're the only places where space-time can actually begin to repair itself, where it can locally reconnect to that perfect, timeless synchrony that it lost so long ago? So are black holes space-time's attempt to heal its own fracture? It's a question that really completely reframes our place in the cosmos.